Let's talk about domain and range of composition of functions further. So let's see f of x is 4 minus x square and g of x is square root of 4 minus x square for f of x and square root of 3 minus x for g of x. Let's start getting the domain and range of both. Domain of f would be, you can plug in any number for x because you're squaring it, but you have to be careful that you're inside the square root. So whatever is inside the square root, which is 4 minus x square, needs to be positive because you cannot do square root otherwise. So if this has to be positive, then x should be between minus 2 and plus 2. So if it goes beyond, say for example 3, then this becomes 4 minus 9, which would be a negative number. So it cannot go beyond minus 2 and plus 2. Fine. So the domain is minus 2 to 2. And what's the range of f? You can see that it's a square root. In order to make this as a function, if you take square root as a function, then you are considering only the positive values of the square root. Therefore, the range of f would be all positive real numbers, that is 0 to infinity. Okay. And what's domain of G? Domain of G is something very important here because the square root again. So 3 minus x should not be a negative number. For that, x cannot be more than 3. Anything more than 3 would give you a negative number inside the square root. Therefore, domain of G would be all real numbers up to 3, including 3. And the range of G again would be all positive real numbers, which is 0 to infinity. So now we need to check whether the condition applies for maybe f of g of x. Okay, let's start with f of g of x. Now it starts with the domain of g goes to the range of g, and the range of g should be a subset of domain of f in order to have the composition of function there, and then the final answer would be in the range of f, and this is what it is all about. Now the condition here is range of g should be a subset of domain of f. So the range of g is 0 to infinity if I make a number line. So it's from 0 onwards. This is range of g, and the domain of f is minus 2 to 2. So this is the domain of f, and definitely the range of g is not a subset of domain of f in this case. Therefore, the composition of function will not be possible for all values of x that you are taking from the domain of g. So I cannot input any value from minus infinity to 3. If I do that, then I'll be getting my output as any value from 0 to infinity, and then I cannot do f on that. Yeah, f of the range of g is not possible for us because the range of g has numbers beyond this point on which f cannot be operated on. So on this place, f cannot be operated there, right? So we can operate the f function only between 0 to 2 because the domain of f is from minus 2 to 2. And if you want to do this composition, you cannot do it on all values of the domain, but you can do on another set of values of domain which give me the range from 0 to 2. If I have that, then the range of g would be a subset of domain of f. In that case, then we can make the f of g of x. So what did I say just now? If I restrict the domain of g here, if I'm not taking from minus infinity to 3, but I'm taking only a smaller set from here for which it is mapped to 0 to 2, then I can do this to 0 to 2, and from here I can do g on this, and then I can do f on this, and then it is okay because 0 to 2 is part of domain of f. If I restrict the domain of g to another set, then I can do f of g of x. So what does that mean? So f of x is equal to square root of 4 minus x square, and g of x was equal to square root of 3 minus x. And we know that the the range of g was 0 to infinity, and the range of the domain of f was -2 to 2. Now we were talking about restricting the domain so that we get only this part for the range of g. This is range of g. So we want to get only 0 to 2 as an answer for this. So what type of x values can you put? Root of 3 minus x can be either 0 to 2. It can be anything between 0 to 2. In order to get 0 from here, I should put x is equal to 3. So for 0, x is equal to 3, and for 2, x is equal to 1. So if I input values from 1 to 3, then I'll get outputs of g from 0 to 2, which is going to be definitely a subset of the domain of f, correct? In that case, I can actually do the composition. If I don't do this, if I don't restrict it to 1 comma 3, then I cannot do f of g of x, correct? So now this x cannot be anything from the domain of g, but it could be only between 1 and 3. If I do it, if I consider the x values between 1 and 3, then I'll get the output between 0 and 2, and then I can easily operate f on 0 and 2 because I can do this. I can do square root of 4 minus x square between 0 and 2, which is possible. Therefore, I can do f of g of x. So the domain, restricted domain now is, this is domain of f of g of x. Sorry, f of g of x. So this is called restricting domain.